This lesson is going to review stoichiometry, which is a lot of the calculations that we did, the mole calculations and various things that we did throughout the semester. So the first one we're going to do is percent composition. This is a part over a whole times 100. So for example, if you were going to do the percent hydrogen in something, you would do the molar mass of hydrogen divided by the molar mass of the whole thing and then times 100. And sometimes they ask you for just one element, or if they say what is the percent composition, that means the percent of each element in the compound. The next type of calculation that we did is called empirical formulas. Empirical formulas you need to know first are the simplest ratios. So for ionic compounds, they are always going to be empirical because we always simplify the ratio. But for covalent compounds, like if you're talking about the sugar that you did in photosynthesis in biology, it's C6H12O6, that is not a simplest ratio. So that is not considered to be an empirical formula. And the steps that you're going to use for this are to make your percents grams first. And you don't need to do anything for that. So you literally just cross off the percent and turn it into grams because you're going to assume 100 grams is your amount. So if you have 30% of 100 is 30. So if you just assume 100 grams, then whatever percents they give you, you automatically have that amount of grams. Then you're going to set up a fence and turn each grams into moles. So use the periodic table, and for each element you're going to turn the grams into moles. You do need to be careful here because if you have a diatomic element, just keep in mind that they're not actually diatomic here. So if it was like oxygen, don't multiply oxygen's mass by 2 because it's going to be bonded to something, so it's not actually diatomic here. Alright, once you have moles of everything, you need to get the simplest ratio. And the easiest way to do that is to divide all of your numbers by the smallest. So whichever of your moles is the smallest number, divide everything by that. That will turn one of them into 1, and sometimes it will fix all of them and you'll get whole number ratios. So if you get whole number ratios here, then you're going to use them as subscripts. If not, then you need to multiply to make them whole. So for example, if you get a number that's like 1.5, you can multiply that by 2 to make it a whole number. However, be careful and make sure that you multiply everything by 2 so that you don't mess up the ratio. And I know these are kind of a lot of steps, so just like the last few chapters, it's really helpful if you go through these steps on an actual problem, and that will help you remember how to do it. So on the review packet, make sure you get to that page where you can practice some of these and check your answers. The next thing are molecular formulas. For molecular formulas, these are the actual formulas. So like I said, for sugar, C6H12O6 is the actual molecular formula. And to solve these problems, you first need to find the mass of the empirical formula. Sometimes this will be given to you in the question. If not, you'll have to go through the steps above to get the empirical formula first. So if the empirical formula was C1H4, you just add up 1 carbon, the molar mass of carbon, and 4 hydrogens. Then you're going to do the molecular mass, which will be given to you in the question, divided by the empirical mass. It's equal to the molar mass. And that will give you a number. That number is going to be used to multiply by all your subscripts. So then you're going to multiply all the subscripts by that number. So for example, in step 2, if you divide them and you get 3 as your number, then just multiply all the subscripts in the empirical formula by 3. And the last thing in this chapter was all kinds of mole calculations. So let's go through that real quick. There are 3 things you can turn the mole into. You can turn it into grams. They might ask you for mass. Grams is the unit, mass is the thing. And to do that, you're going to use the periodic table. So it depends on what chemical it is for what number you would use for that calculation. You can also turn it into liters if it's a gas at STP. And a lot of times it'll say STP in the question. That's kind of your clue that you can do this. Keep in mind that liters and volume are the same thing. Liters is the unit, volume is the thing. And for this, you're going to say that there are 22.4 liters in 1 mole. And that conversion factor is in your reference packet. And then the last thing you can turn it into is particles. You won't actually see the word particles, you'll see the name of the particles. So you might see atoms, you might see molecules, you might see formula unit. And for this one, we are going to use Avogadro's number. There are 6.02 times 10 to the 23rd particles in 1 mole. And again, that is in your reference packet as well. Once you get it into moles, we'll call these moles of A. This would be grams of A, liters of A, and particles of A. We can turn it into a different chemical using a balanced reaction. So to get from moles of A to moles of B, you are going to use a balanced reaction. RxN stands for reaction, and you're going to use those coefficients. So the coefficients in the balanced reaction are the mole-to-mole ratios. So this is where you set moles on top of moles in your fence, and it allows you to switch from one chemical to another. And the way you know to do that is because in the question, it will give you information about one chemical, and it'll ask you about something different. And a lot of times the question will also give you a balanced reaction, so that's another clue. And so then you have to get it into moles first. If it's in grams, you have to first get it into moles. Then you can use those coefficients in the reaction to do moles on top of moles. And that is the only step in this fence where mole does not get a 1. When you're switching from moles to moles, that's where you use those coefficients. It might be 1 if that's what it is in the reaction, but if it's a 2 or 3 or something in the reaction, that's what you're going to use for moles. And then once you have moles of your new chemical, so moles of B, you can then go to anything else. So you can go to liters of B using 22.4. You can go to grams of B using the periodic table. It'll be a new number because B is a new kind of compound or chemical. And you can go to particles of B. And like I said, it's better if you can practice some of these and set up these fences. It will make a whole lot more sense to you. And if you need more instruction, there are some detailed videos in some of the previous lessons that we did from Stoichiometry to help you with this. And that's it for today.